Should be any second.
Could be now. I think we're on, gentlemen.
I'm streaming.
Yeah. Well, listen, I'm going to start the show. Is that all right with the rest of you gentlemen of the board?
Go for it. Is.
Ladies and gentlemen, hello there. Welcome aboard. It's the SBAU Astro Hour, a weekly podcast and blog for Santa Barbara Astronomical Unit, where members of our South Coast Longtime Telescope and Astronomy Club get together in our Monday man caves and computer dens to talk about space launches and discoveries and astrophysics, and our SBAU members and stargazers who might want to join our club, watch on YouTube. It's our 82nd episode, and I'm Vice President Ron Herron for 4 years. Introduce you to the gang here right after I do a couple of headlines. Check in this week on our solar system neighbors, Mercury, Jupiter, and we're going to learn some new stuff about Saturn. Boy, it blew me away. Meteorological or autumnal equinox. We have 2 equinoxes, 2 different dates. We'll talk about that. We got 2 comets now. The old PanSTARRS is still out there, and a brand new one that's coming in from above, and a nebula named Snowball, a blue snowball, plus a galaxy named after a cigar. Let's meet the gang from the board of SBAU. Jerry Wilson, housewife Pat. Jerry, president.
Hi, good morning.
5 years for you. 2 of them by default because we had a pandemic and we're still in it. Haven't met, but anyway, let's meet Chuck McPartland, our outstanding outreach coordinator, whose wife is the merchandise manager and also named Pat, and sits in support of Ukraine in front of their flag. Tom Totten joins us this week, and he was the man in charge. He still is the webmaster, technical wizard, married to Cezanne, the artiste, and off last week because of a stupid, silly excuse, having eye surgery, is Tom Whittemore. You got your brand new lenses in, Tom?
This one.
Oh, just one.
Unfortunately, I can see you really well now.
That's the downside.
Yeah.
Aren't you supposed to have I did it and I wore a patch, I think, for a few days. But you took it off, I guess.
It was pretty straightforward. It was for a cataract.
Just one? You're not going to have the other one done?
Yes, I will next Monday. In fact, I won't be able to join you because I'll be on the table.
Okay. Well, ask your ophthalmologist to look at the lens if he's got one before he puts it in, or at least a version, because I saw it and I swear it looks like a little galaxy.
Wow.
Round lens with 2 little hooks that are opposite each other, and I swear they look like arms of a galaxy.
Yeah.
He was former Westmont College science instructor, sobs about it against the bathroom mirror every day, editor of our newsletter, and doggone, we don't have Bruce on board, but we got a lot to talk about, and going to start things with some presidential Jerry levity, the silly science cartoons that he sends us.
Tim just joined us, by the way.
Huh?
Tim Crawford just joined in.
Oh, hello there. Okay, Captain. I think is this range anxiety? Yeah. Here's what I wrote. It's an electronic spaceship, or electrical, for those of you who drive Teslas. It's a giant electrified mothership deep in space. Shares a quick exchange from the crew. Captain, I'm having range anxiety on the CB. Captain replies, yep, I know, Spock. We haven't even reached Andromeda yet. The batteries are down 60%. There's no place to charge out there. I don't know where you find them, Jer, but here we go. A kitty cat one. Couple of aliens are about to kidnap the human. I'll grab the human, you take the cat. And guess who got the worst of it? One of your cats. All right, show that to the kitties. Speaking of kitties, here's Heathcliff standing at the observatory door, and woman says to him, if we find the cat planet, I'm gone with you. Okay. Or going with you. What is that? Is there a cat planet? Did I miss something on that one?
No, not that I know of.
All right.
There's a lion, but that's a constellation.
I like this one because if you're wondering why you're being separated from your loved one after all these years, try this. Ralph and Ethel gradually drifting apart due to the universe expanding. It'll happen. Oh, this one. Did I see this? Okay, now when a teacher comes out, the kid says on the teeter-totter, everybody looks straight up. Drive me nuts. Okay, incoming. And there's a couple aliens. The human race wasn't very advanced. Apparently, this is after the apocalypse. They mostly spoke in monosyllabic grunts, monosyllables, right? In fact, the last words from their civilization before the meteor hit, OMG, that's oh my God, and WTF, what there's a word there that
Frack. What the frack?
Yeah. Oh, this is crazy. This is the drugs two addicts standing before a tapestry of hallucinogenic patterns and fractals and calculus style functions. And one says to the other, you know, I'm finding these drugs a little bit mathy, aren't you? Woo! Strange. Oh, and then there's a planet. What is this one here?
Pollution.
Bad news, bad and good. We have irreversibly polluted our own atmosphere, and there's so much space junk out there now, we have completely blocked out the sun. On the good side, though, it's that we seem to have solved our global warming problem. The sun can't get through. I think somebody's doing something about that, aren't they? They're going after, we did this one, or did we?
Yep.
All right.
We're done.
Lots to talk about, including some great new stuff. And if you want to follow your talking points from the beginning, Scootum the Shield to you, since later on we'll do the planets. What the heck is Scootum? Great time right now to check it out, right? Early in the evening sky for the, it's a small constellation. Am I pronouncing it right? It's not
Scootum. Yeah.
Scootum. All right.
Yeah. Jerry, if I could throw in a couple of cents on that one, I'd love to.
Yeah, go ahead.
Oh, okay. So Scootum, yeah, now it's called Scootum. Of course, it's the shield. It's the shield. It's a real tiny constellation. But a long, long, long time ago, it was known as John Sobieski's shield. And again, I'm always, proud of my Polish background. But Sobieski was a kind of a hero in Polish history. And Hevelius, who was a Polish astronomer, named this particular constellation, and it still is a constellation, but now it's called Scootum shield, but it used to be John Sobieski's shield. Another thing I wanted to mention is Delta Scuti is a very famous variable star, and it's basically the model for the kind of variable stars I used to study at Westmont, these short period variable stars.
There's Delta right here in the middle of the constellation.
There we go. Okay. That's kind of dear to my heart because it's a group of, if you like, variable stars that I studied, when I was working the big scope at Westmont. And these are short period variable stars. And this particular one, I think, pulsates over the course of 4 or 5 hours, roughly. And it changes by about 0.2 in magnitude scale. So it's easily visible in any large telescope, especially a scope that's equipped with a camera. And I guess Lick Observatory studied this particular thing in the 30s, back in the 1930s, and found out it had a whole variety of different modes. So it doesn't just breathe, if you like, radially, but it has all these oscillations that go around the star itself. The star's about 200 light years away, and so it's sort of a close neighbor. So there's my 2 cents, Jerry. Thanks.
Okay. Well, this is of particular note this season because of M11, these two open clusters, M11. I don't know why there's a dot in the middle of the open cluster. There must be something else in it. And M26, another bright open cluster. So these are very, very nice sparkly objects to look at in your amateur telescope. M11, we covered that quite a bit last week, the flying duck cluster.
Mm-hmm.
Oh, the duck.
The wild ducks.
The wild ducks.
It should be the wild ducks. It's supposed to be a flock of ducks.
Yeah. And to me, in a small scope, it does have the shape of a V, the shape of a V, like a bunch of ducks flying in a V form.
Okay.
By the way, Tom, as an aside, Friday, did you meet the new astrophysicist there at Westmont?
Yeah.
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 Okay. She seemed real nice.
Dr. Ito, Chuck and I both met her, and she's wonderful. She was hired by Westmont this year as basically the astrophysics person, and her background is in the microwave background, so early radiation, from the universe. So that's her field of interest.
Had a good crowd, good turnout.
Yeah, 204.
Wow. Yeah, sorry, I pooped out a little bit early, Chuck. I was kind of pooped, you know.
Hey, you had your eye operated on. You're
Yeah.
excused.
Well, I did help. I helped Tim collimate his scope, so I felt valuable anyway.
Well, can you see through the lens with the new eye or the old eye?
Oh yeah, no. It's really good, Ron. In fact, when I put my glasses on, which are probably a few years old as far as the prescription goes, it's almost dead on. The left eye almost dead on. The right eye has never been bad at all. It's just the left eye sort of accelerated in the cataract because I had a detached retina in that eye, and apparently when you have that repaired, it kind of accelerates the advent of a cataract. So that's what happened.
Didn't know that.
It fixed my seeing perfectly, but I get a corona around bright lights sometime, one of the eyes.
That tells me you probably still have something going on there as far as the cataract. You know, when you see those halos, if your car is coming towards you at night.
Oh,
yeah, that thing scared me, you know, because I was seeing those things, and it wasn't.
I'd go home from Saturday night star party and be scared to death on the roads of Santa Barbara. What are we looking at, Mr. President?
Okay.
Next topic. We're looking at one of the two comets. This one we've been looking at for a long time. PanSTARRS. It's sort of doing its swan song in the constellation of Scorpius. You can see it down here. Can you see my hand?
Yes.
Mm-hmm.
Yeah. The bright Antares here. This is a summer constellation, and as we get toward the fall, this is only up for a short time in the evenings. This particular doesn't have a time, but you look right after, you can see the sky sort of light here and dark up there. So before it gets completely dark and before Scorpius has completely disappeared, you can find PanSTARRS this week right down around there. This is the southwest and the south. So you need a very good southwest horizon to see this.
And it's going to move from night to night. So this is only good probably for one or two nights.
I think this is good for today.
Okay.
That's PanSTARRS, discovered what, last year?
A couple of years ago.
Yeah.
We've been watching it all last year.
I don't have the long numerical name, just PanSTARRS. And then you want to introduce us to the new one?
Yeah, E3. Oh, there it is, the discovery photo. Oh, there. This is the comet, coma, head, tail, all there, all the features. It is, it was discovered in March of this year, and it's quite faint. It's around 13th magnitude right now. Today, it's about 17th magnitude right now. Oh, that's when it was discovered. I read that it's about 13th magnitude right now. It is coming in, it's way out of the plane of our solar system. It's coming in this way and going down. So we will see it in the northern hemisphere, which is us, up till its perihelion nearest approach around February of 2023. And then it will be a southern object like that. It's going to travel pretty fast.
That's interesting. If you look, I'm sorry. Okay, that's nearest approach. I was looking at the declination and seeing it go up. So I'm thinking, it must be coming south to north. But then that last one is nearest approach.
Yeah.
Not its ultimate destination.
Well, it's my understanding that the Kuiper belt, which is just beyond the plane of the planets, is also on the plane, is it not? It's not a shell like the.
That's correct.
What?
That's correct.
Okay, so this baby
it does widen out as you get farther and farther out. It widens out and basically blends into the Oort cloud.
Yeah.
So where do we get comets? The Oort or the Kuiper?
Both.
We get them from three sources: Kuiper, Oort, and interstellar. The
asteroid belt.
Yeah, we get them either Oort.
Yeah. Right. There's a good mnemonic.
Yeah.
We've had
don't mention that again, Tom. So what was I going to say? I forgot.
Kuiper belt.
The origin of this comet has not yet been determined.
Well, I can give you its full name. It's 2022 E3, as you said, ZTF. I don't know what those letters stand for, but
Read a little
Zwicky.
farther down into the talking point.
Yeah, Zwicky Transient Facility.
all right, it's 4 times the distance of us from the sun, 4 AUs. Very dim right now, hard to see. Use a big scope, should come close enough to Earth by early 23, I think January 13th. It'll reach perihelion, right?
Mhm.
Just a little.
So go ahead.
Just a little more than an astronomical unit, so which is 1.11 AU. That term has a lot of meaning to us. 27 million miles away by February 2nd.
Mhm.
And they don't know if it's been here before or not.
No, don't know much about it yet. They're hoping that it will become a binocular object and reach about magnitude, maybe 6 or 7 is the projection. It is called E3 because the comets are named in the order in which they're discovered. And they get a alphabetical thing for the half month into the year. So it's discovered in 2022, and it was in the 5th half month of this year. So it gets E, and it was the 3rd object discovered in that half month.
And it's not going to get near the sun at all.
There's going to be a test.
Okay, but I thought comets came in close to the sun. That's how they got their tails. This sucker.
This is close to the sun.
You mean because it's never going to be closer than we are, right?
No, but that's close enough. It came from way, way out. Probably.
It was already active 4 AU away. You know, it doesn't take much.
Okay. But yet we have asteroids almost colliding, or at least passing us all the time, but they don't do a tail, do they?
Some of them do.
Yeah, some of them are not completely converted from comets.
Well, the tail is always dependent on how much water, something that can turn into a gas.
Volatiles, yeah.
Yeah, volatile. CO2, water, methane, nitrogen, all sorts of crap.
Okay, this is what I was going to ask. Where are we going to see it?
Okay.
Okay.
So here's Ophiuchus. Here is Scutum. And up here, the dates are kind of hard to read, but this is 4/18/22, 5/22, 7/14/22, 8/1/22, 9/15/22. So that's about where it is now.
Pretty high overhead.
Yeah. This is Hercules. And Lyra with Alpha, what is it, Vega in it. And then it's going to swing down here on November 14, and then it's going to go up by January 13, 23. It's going to be, and you see the dots are getting far apart. So from our point of view, it's speeding up.
Yeah, it's just streaming going in declination, towards the north.
Yeah.
That's what Chuck was sort of pointing out a bit ago.
Yes, yes.
So that's the perihelion we're looking at?
That's heading into perihelion.
This is the apparent path of the comet on our sky, which is not an easy geometric figure to describe or draw.
We're all moving.
Yeah.
And thank God for computers, huh, Chuck?
Yeah.
But do most comets come in from all those different directions, or are most of them on our plane of orbital planetary transition around the sun?
Well, the ones that come in kind of in the orbital, closer to the orbital plane, are the ones that have been captured and affected by Jupiter, and they're short period comets. So depending on whether you mean appear most or come from most.
Yeah, back in the 90s, one of them broke up and became a bunch of rocks that landed on, is that Hale Bopp? No.
Shoemaker-Levy.
Shoemaker-Levy, yeah.
Shoemaker-Levy, yeah.
Oh, the one that hit Jupiter.
Yeah.
The 9 that hit Jupiter.
That would have been on our plane. What is Halley's like? It goes in close to the sun, doesn't it?
Not real close.
Yeah.
Okay, but
I mean, closer than this one, but
Yeah. It periodically makes a dramatic sky display.
I've seen it for my one and only time.
You never know.
Too.
Medical science may get very good all of a sudden.
Duck, there's 2 aliens at your door that want to take you and the cat away.
No, it's near the cat snacky time, so they get friendly.
Oh, look who's joining us.
Yes, hello.
Mr. Bruce Murdoch finally got the
Good
right
morning, Bruce.
connection.
Right, I was involved in a medical Zoom meeting, so
Well, that's a cheap excuse. We'll buy it this time, but don't let it happen again.
it's an expensive excuse.
Good. We have a full house today. 6. You missed a lot of good stuff, but there's more good coming. So is that it for the incredible? Are you any of you guys going to go watch for that new? Can you see it with your telescopes in our light situation here?
Yes, well, you can do it with a photograph. It's what, about 13th magnitude. So that's the theoretical limit for a 6-inch refractor or reflector under perfect dark skies.
We don't have that.
No, so it's going to be a photograph with a small reflector or a gigando reflector like Joe Doyle's 18-inch.
And leave the lens open?
Well, what?
In other words, you can't just see it with the eye one time. You got to leave the lens open and let.
If your scope's big enough, you'll see it with your eyes.
Yeah.
Oh, okay.
I'm sure Charles Schuler's 20-inch ES scope would get it.
Uh-huh.
Yeah, that's what we were trying to remember the other day, who had the largest scope in our club, and I forgot Schuler.
Yeah,
My apologies.
and he's got that on a tracking mount too.
Yeah, okay.
Well, good luck. Apparently, we see this better in the northern hemisphere than they do in the south right now. But that
Right now, yes. In fact, they can't see it at all right now.
Okay. You ready to go to the southern sky with the cigar galaxy?
Yeah, well, this is actually the northern sky, but it's the extreme southern part of it. You can see Aquarius up there and Cetus. This is a constellation that gets down close to the horizon. And this is 1 a.m. on September 19th. So it's 1 a.m. night.
Oh, 1 a.m. this morning.
Yeah.
Yeah, 1 a.m. this morning. Yeah. So it'll be the same thing 1 a.m. tomorrow morning too.
Yeah.
This is not a comet. It's not whipping across the sky. This is a bright southern star called Fomolo in Pisces Australis. And that one you can just barely see sometimes from my place in the southern sky if you're up on the balcony. So this is a challenge. Again, you need a very good southern horizon to see this. This is about as high as it gets. It is the cigar galaxy. It is an interesting spiral galaxy that we're looking edge on.
That's why.
I'm trying to find a good description of it. This is the central core of the galaxy, central bulge. It's obviously got one eccentric arm out here, and the other arm either goes back this way or out this way. So, or maybe it's just lopsided. Maybe it had a scary approach from another one a while ago, and it still hasn't gotten over it. But it's a bright, dramatic object. It probably won't look so bright in our scopes here if you find it in the southern sky, because that's not a real clear sight. Although our southern sky is looking out over the ocean, and sometimes you can get really surprisingly good seeing and clarity or darkness.
When I took a picture of M8, the Lagoon Nebula, that was out over the ocean, and that was before they changed out all of our streetlights, and that was a really good picture.
Mm-hmm.
Now, is this part of the local group, like your Magellanic Clouds?
No.
No, I don't think so.
That's not
Yeah,
why
that's
it's
pretty far south, Ron. That's pretty far south. I mean, we have a really good southern horizon. I would be pushing it to see this guy.
Wow.
This is a challenge of the week.
Yeah.
So we know why they call it the cigar, and it's also called the NGC 55.
Mm-hmm.
And it's the southern cigar because the better known cigar is up near Ursa Major, up near the Big Dipper.
Well, don't forget the cigar shape of a Muamua.
Yeah.
That's really long.
What is the sculptor? Is that a galaxy?
Yes.
No,
Or
Or constellation.
Constellation,
the
right.
Constellation. And there's a lot of really neat galaxies, the sculptor group.
One of the 88, is it Michelangelo depicted or something by stars? Or?
Sculptor, no.
No,
It's the
no way.
sculptor's studio, it's supposed to be.
Boy, Tom Totten talks about that in the planetarium these days, doesn't he? Isn't he doing shows again? Tom, are you still with us?
Yeah, I'm still there. Just no planetarium shows for the summer stopped for me. I did Fridays.
Yeah.
Chuck did one yesterday.
It
Yeah.
did too.
You and
Few.
Chrissy Cook.
Yeah. The most beautiful galaxy in the sculptor group to me is NGC 253. If I got that number right.
Yeah, the
And
silver coin.
Yeah, and that was discovered by what's her face?
Carolyn Herschel.
Herschel. And I saw that at one of the Cal Star parties through my 18-inch back in the early 2000s, and it was just phenomenal. And Tim still talks about it. Yeah, Tim took a look through the scope then.
Tim Crawford, is he still on board with us this morning?
Yeah, he's still on text.
Tim, throw us a question, will you? For crying out loud, be involved. That's a neat picture. Has the web taken a shot of this sucker yet?
No.
Not that I know of. This is probably a Earth-based telescope.
Yeah.
It's processed excellently. You can see the orange color of these stars down here, along with white stars and blue stars. You can see the blue, subtle blue, the robin's egg blue of the galaxy out in the arms, and the yellow gold core. So this is processed very well for color. It's not overstretched. Good,
Yeah,
good
you can even
process.
see some of the dark clouds in the galaxy.
Oh yeah, yeah, in here.
With hints of the pinkish hydrogen.
Yeah, right in here. Yeah.
Last night I looked out and both Betelgeuse and Mars were very colorful. They were orange.
Yeah.
Yeah.
I saw it come up at midnight.
Yeah, well, that's about 1 a.m., I guess.
Yeah.
Well, next we're going to switch from color balance to one color.
Blue.
Tim will like this one. Tim likes the blue snowball.
Yeah.
Okay.
AKA NGC 7662.
Yes, and this is tomorrow night at 10 p.m.
Okay.
It's in, and it's not moving with respect to the sky. This will still be about the same. So this is the end of Cassiopeia, and down here is M31 Andromeda, and farther down is M33 with Merak, splitting the difference right between them. If you draw a line from Merak to Polaris, it goes right through the heart of Cassiopeia, just like a arrow through a bow. It's the easy star hop that I do to find those for outreach.
So Jerry, Tim Crawford put down earlier about to find the blue snowball. It makes a perfect equilateral triangle with the with Scheat star and Alpheratz, which are part of the Pegasus or Andromeda.
Yeah. Scheat's over here, and Alpheratz is here, so it makes a perfect right triangle or equilateral triangle. But you can just follow this red line up. That's a joke.
Yeah, follow the red line. Yeah, sure.
Yeah.
Okay. I guess there's a time delay.
My understanding is that blue means hotter, doesn't it? Usually when you talk about stars.
Yeah.
Not in this case.
Yeah, it does when you talk about stars.
Yeah.
Okay, but not in this case.
So this is a small, tight planetary nebula. It can easily be confused with a star, but not in this particular picture, which is a Hubble picture. There's the star that's the remnant of it, and this is the blue snowball. It does stand out. It is so intensely bright, but very small, that it almost triggers your color sensors in your eyes. And that's what gives it that bluish hue to you.
So who took this? Is Hubble, this picture?
I think so.
Okay.
Webb will do even better than this.
Yeah.
Well,
So-
it isn't going to see the blue very well.
You
Yeah.
can make it see any color you want, but
They can make it any color you want, but
yeah.
What is the pink?
Hydrogen.
Hydrogen.
Really? There's not much in there.
Those are H2 regions, Ron.
In other words, uncooked hydrogen that hasn't fused inside. The rest-
It's no longer hydrogen.
Hydrogen's a very light element. When this thing sloughs off its outer core and it has an intense solar wind, hydrogen's going to do the most traveling.
Yeah, but it's also the most plentiful. It's everywhere.
how big is this? What's the angular substance that we would look at?
A minute? Let me
Oh,
look.
wow, tiny, okay.
Yeah, it is tiny.
Just 2 arc minutes here in the caption.
Oh, yeah.
The white
Yeah,
dot.
2 arc minutes.
Oh, I didn't read the caption. Okay, yeah.
It says the radius is, well, the diameter be 1.6 light year.
Oh,
At that distance. You can figure it out. You can
Yeah,
figure out
take
the
a
distance
note.
from that.
Right.
Wikipedia lists the distance between 2,000 and 6,000 light years away.
Okay.
So why can't they nail that down better? I don't know.
Because these aren't uniform in brightness. If they actually knew the diameter and they know how many arc minutes it subtends, then you could calculate it. But
Right.
a
And
lot
there's
of them
no-
they get by watching the spectral lines and seeing how they're shifted, so they know how fast the stuff is moving away from the core. And then they take a picture a little bit later and see how much angular distance it's moved, and that lets you calculate a distance. But otherwise, these things are not uniform in brightness, so it's pretty hard to get their distances.
It is, and they're not, the central core star is not a Cepheid variable, so if it was, they could pin it down,
Yeah.
but it's a white dwarf.
White dwarf.
now are we looking at a face-on flat fried egg, or are we looking at a round ball that would look the same no matter which area, which angle we were looking at?
I don't know that.
You can't tell. It might be hourglass shaped and you're looking at it end on.
Yeah.
Oh, geez. You'd think science would know. Are we looking through the outer blue into the lighter blue? And
Well,
This side?
that's most likely, yeah, but you would have to get spectral lines on it to tell how the pieces are moving. That's how they know the ring nebula is actually hourglass shaped.
and it's misnamed planetary nebula, even though there's not necessarily any planets involved, right?
Well, that's because they saw this greenish blue color in these, and they also had just discovered the planets Uranus and Neptune, and those look bluish. And so they said, these are clouds that look like planets.
And both Neptune and Uranus are each about 2 minutes of an arc across. And so this looked, in old telescopes, visually, this looked very much like a planet.
Wow.
It says in Wikipedia that the central star of the planetary nebula is an O-type star. So
Yeah.
it's not a white dwarf yet?
What does Wikipedia say?
It says it's an O-type star.
That's a spectral
A hot-
class. It means it's
A
very
hot
hot.
white blue star of,
Yeah.
spectral O.
Yeah. Yeah, but if you on a Hertzsprung-Russell diagram, it'd be over by the O, but way down.
Right. Right. It's very hot. It's very hot. So something 100,000 kelvins, something like
It says
that.
it says 30,000 Kelvin,
That's good. Yeah.
Yeah, that's
Right.
okay.
but
Some of the O-types
is it-
go up to 60 Kelvin, 60,000. 60
So
Kelvin.
so a O-type star is a white dwarf then?
No.
Oh, no, not at all.
There's O-type, there's main sequence, there's O-type giants, there's O-type white dwarfs.
Yeah, I
That's
guess
just
so.
talking about the temperature, surface temperature.
Yeah, the luminosity and temperature.
Is there a difference between the inner shell of blue around that white dot and the outer shell of darker blue with the pink? Are they two different?
The darker shell, you're probably looking through more material.
Oh,
Those are probably two different pulses of barfing off outer layers.
Yeah.
okay, gotcha. And did they know how long ago this happened?
It's going to be within 60,000 years.
Okay, but the whole thing we're looking at would fit between us and Alpha Centauri, wouldn't it?
Yes.
Like light year or two left over on both sides.
Yeah, it would take a quarter of the distance,
Okay. Wow.
or half the distance.
Fantastic. Blue Snowball, aka NGC 7662. You want to talk about equinoxes, gentlemen?
Okay.
I learned something with this, and I don't know how they say there's a meteorological equinox that started September 1st, which would have been, 19 days ago, as opposed to the fall equinox, which falls at 6:04 p.m. this Thursday evening, Pacific Daylight Time. And I always thought it was when the sun's directly over the equator, thus the word equinox, and heading south, I guess, so that we head into winter and they head into spring. So 6:04 is the regular autumnal, but What does the meteorological equinox mean, Mr. President, or anybody? Because I've never heard of it before.
I haven't either.
You got me.
Wait a second, I'm lost here.
It's another one of those weird astronomy magazine things.
Yeah,
Well, I've always
that
wondered.
is a clipping from Astronomy Magazine. And
I've always wondered why
where am I here?
the four seasons start on a date. For example, December 21st is the beginning of winter, but it should be somewhere in January or February in the dead middle of it, shouldn't it? When it's the winter.
The meteorological autumn is just a time when the weather changes that traditionally, and they label it as September 1st. It's just a fraction of the year in meteorology.
Okay.
And meteorology is known for taking misleadingly labeling things. For example, if you see a certain type of cloud structure, it's called a gravitational wave or gravity wave.
Gravity wave,
And
yeah.
there's nothing to do with that. And so gravity waves, when we first detected them, we had to call them gravitational waves so we wouldn't conflict them with the cloud formation. So, but what we deal with as astronomy is the autumnal equinox. That's the start of the astronomical season of autumn.
Mhm.
That happens this Thursday at 6:04 p.m., which is what, the 19, 20, 21,
22nd.
Yeah.
Yeah, so I was just going to mention that since June 22nd or so, the sun has been starting to move further and further and further south. Okay. And at that time, was it the 22nd, Jerry, of September?
Yeah.
But then it crosses the celestial equator and it's moving south. Okay.
Yeah. And when you're driving on the 101 out toward Gaviota, you get the sun right in your eyes at sunset.
Oh, it's pretty horrible on Foothill too, Chuck.
Yeah.
Well, I'd like to take note or tell you guys, if you don't believe this, that September ushered in our hottest days. Right after the first, we had about a week, didn't we? It was last week.
It was quite spectacular. Yeah, that was meteorological.
Yeah.
So the meteorological seasons are, autumn for September 1st, winter December 1st, and 3 months later it's spring, and 3 months later, June, it's
Summer.
summer. Yeah, I got a pop up here. My pop up rejection stuff is not working as well anymore.
Mm.
But on the equator, in the tropical zones in the middle of the Earth, there are no real seasons. It's just hot or hotter, right?
Yeah. Wet or not wet.
Yeah, and you can grow anytime you want. There's no harvesting in the fall and planting in the spring for them. They just flooded with fruit and vegetables.
And it rains every day,
Yeah.
sometimes.
What do we got going here, Mr. President?
So the showpiece we were just looking at over here at M55, or no, that was the blue snowball up here. And now in the same field, way over on the same field of my my planetarium is M15.
Yeah, that's a real beauty.
Which is supposedly the showpiece of the autumn sky. It's a dramatically bright globular cluster.
Yeah, it's globular. It's spectacular, Jerry, as you know. And it's right off the nose of the horse, right off the peanut.
And this is it. And there's a number of features in it. You just think, wow, a big spray of stars, but it is. It's actually got a planetary nebula in it, which I'm not able to point out to you in this diagram. It's got a lot of black lanes in it that I think are real star pattern holes, not nebula, because this has got such a locally intense solar wind that it pretty much has blown all the dust away from it. But you can see sort of dark lanes. And these dark lanes, once you have looked at these things enough, those dark lanes are the signature by which you can recognize if someone shows you a globular cluster. People that aren't familiar with it think they all look the same, but they don't. what is it?
M13.
M13.
13 has those pretty structures, Jerry.
Yeah, it does. It has sort of a tri-part radial propeller-like look to it. This one, I've looked for it many times and found it, and then I've lost it again, the planetary. But it was the first planetary discovered in a globular cluster. And I think since then there's been about just a handful, half a dozen or something discovered.
There's a black hole in the middle of this sucker, isn't there?
Suspected.
There could be.
Huh.
There's also, if you're in a really dark site, this apparently is right on the verge of naked eye visibility because there are Arab stories about a fly by the nose of the horse.
Oh, that's pretty cool.
What's the 15th object discovered by old man Messier? It's also known as NGC 7078, with about what, 3,000 stars?
No, hundreds of thousands.
Oh,
Yeah.
3,000 was the other one that we just went through.
Yeah, it's 175,000 light years in diameter.
No, 175.
Oh, excuse me.
Yeah.
175. I was also looking at 35,700 light years from Earth.
Yeah.
That
Yeah,
sounds
that
right.
would put it bigger than the Milky Way.
Densely packed and
Yeah.
core,
It has
core contraction or core collapse.
core collapse.
Wow.
So it has a central density with an enormous number of stars surrounding what may be a central black hole.
God, you'd think every so often we'd have gravitational waves from that sucker with collisions, you know? A couple stars just out of how many
It takes something
stars?
supermassive to cause gravitational waves. I don't think a star would do it.
Well, it would cause waves, but we won't be able to detect them. That's
Right,
for sure.
right.
Okay.
Exactamundo.
It's a fall favorite, and it gets pretty high up in the sky.
Mhm.
Those LIGO detectors don't always shake, do they, around the country?
Well, there's only two of them.
I know, but are they watching them all the time? How often do we get
Yeah.
two
Yes.
black holes?
Except when they're upgrading them. Yeah, and now there's four. There's an Italian
Right.
LIGO, basically, and I think there's a Japanese one.
Wow.
So now they can really zero in on the location that the gravitational waves are coming from.
Mhm.
It's
Well, they were
amazing
really-
that the gravitational waves are moving the mirrors a very small fraction of the diameter of a proton.
Well, but because they're so far away, these things that are happening, if a couple of black holes got together in our own neighborhood, it would really probably shake it, wouldn't it?
Oh, yeah. Get a bigger effect closer in.
Might even affect
Would
us.
would we notice it
No,
as people?
No, it wouldn't register on the Richter scale.
Yeah, I didn't think so.
Yeah.
yeah, Einstein predicted these and said there's no way we're ever going to be able to detect them. They're so
Yeah.
weak. But
That's right.
Well,
Yeah.
what does he know?
Okay, we'll have note from the planetary, briefly from the planetary happenings. This is, of course, Jupiter, but Mercury is now in inferior conjunction this week and will pop up in the evening skies,
morning sky.
morning skies.
Yeah, it's going to flip. Mhm.
Yeah,
If Jupiter is nice and
the
bright,
morning sky by October. So the thing is, Jupiter is near opposition, and the way you tell that is you can put a stick in the ground and see that the shadow of the sun of Jupiter is right down the stick, and that stick for us is going to be something transiting like Io, and the moon and its shadow are going to be so close together this week, and that's the feature to look for. This is the 23rd, which is what, Thursday?
Yeah, Friday.
Friday at 11 p.m. Eastern Standard Time. So that's 8
p.m. our time.
Yeah, our time.
that's
So
too
this is
early.
something that probably won't be up by then, or it'll be low in the east.
It'll be low.
Io goes around Jupiter at what? I've forgotten the period, but it's pretty
2
quick.
days, I think.
Yeah.
Well, your talking point said it's nearing opposition September 26th, which is a week from today, our next podcast.
Yes, but it's close to it. You see, Io and its shadow do not go right over each other. They would if at exactly at conjunction,
Mhm.
if we're in the same plane.
Is that the only moon that does it, that transits?
No, no.
Oh, no.
Well, it
It's the
keeps saying
closest
there's,
moon in it.
what's the other one?
All four of them do. All four of the Galileans.
Oh, okay.
But Io's the closest one and transit more often.
Or Io is just wrenched being that close to Jupiter, isn't it?
Well, that's what keeps it hot.
I know, spouting those.
And this is a diagram, it's not to scale.
Uh-huh.
So the shadow is not to scale either?
No,
Well, can you guys see that?
It's reasonable though.
Is
oh
this,
yeah, you can see Io easy and even in a small scope. And you can generally see the shadow too.
Yeah. Although Io's a little hard to see depending where it is on the planet because those bright bands would kind of hide it.
Yeah,
The shadow really shows.
well, how long does it take to transit clear across?
Hour or two
An hour?
in that neighborhood.
Okay. So we're looking at Thursday for the crossing, but next Monday will be the opposition.
yes.
Ah, got it.
This transition is close to opposition, and there might be one that's closer, but that would be next week, and we're just looking at this week.
Sure.
Well, 26 is Sunday.
Right. Okay.
Yeah.
Fascinating stuff. Now, Saturn really gives us, is this Saturn's ring or?
Yeah.
But that's Saturn's ring.
Okay, an icy moon torn apart in Saturn's gravitation field 150 million years ago probably explains why the planet's rings are so young. And
150 million years.
good Lord.
This is a great picture. This timing was wonderful, isn't it?
Yeah. This is Titan in the background, and what is that? Enceladus?
Titan is the bigger ball, and then the
Dione.
foreground.
It's Dione, and this is Pan.
Okay, but the ring, Saturn would be off the picture then to the left, right?
Yes.
Yeah, this is heading towards Saturn.
Okay.
And you can see another tiny moon in the gap over there on the far left.
Yeah, little shepherd moon over there.
So it was in Science magazine, the guy's named Jack Wisdom of MIT and some colleagues came up with a new tidal forces theory, tore apart.
And he has a fairly intricate hypothesis about how the rings formed. The difficulty is accounting for them forming and being so young. And he's worked that out with modeling computations. And apparently there was another moon in Jupiter's system that was about the size of Dione or Enceladus or one of the other larger ice moons. And it was perturbed. It was not in a stable orbit. It came close to Jupiter. And the options were that it either got flung out of Jupiter's system or that it came inside the Roche limit and was torn apart by tidal forces from Saturn. And based on that, he's able to predict the ring's properties.
And that actually, that's been around a while because I remember hearing that a couple of years ago. But back then the speculation was a Titan-sized moon, not a smaller one.
Yeah.
So
This one, and it's easy. I was thinking about that. Is this really for us? Because it has been around for a long time that that's what happened. But it's easy to speculate about something and be right about it. But you still need to have a firmer basis than that. It feels like that's what's happening. We call those arm waving discussions. So, but this guy pinned it down with his computational hypothesis.
well, if it was thrown out of the system, something had to make the rings, fill it with matter,
Well,
ice chunks, and so it'd have to be another planet or another moon, right?
well, no, this is the hypothesis then was it was Saturn rotating so quickly that stuff got flung out from it. But
Yeah.
that just angular momentum wise doesn't work.
But yeah, all those gas giants out there have, even the smaller ones, Uranus and Neptune have rings. So rings seem to be the rule.
They're common.
Is it something like the Lagrange point that is at play here?
No, it's just a conservation of angular momentum.
Yeah.
If you have a donut of debris, it will collapse down into a ring.
Mhm.
And they never decide to reform again into one ball.
No.
God, but they
You
do.
can't, they're being,
Too small.
yeah, just like the asteroids never formed into one planet because of Jupiter.
Oh,
Keeps tearing them apart again every time they get close to being there next to each other. They're redistributed. Jupiter's a bit of a tyrant there.
but according to your notes, Mr. President, there is a Neptune connection. Now that's three.
It's at, yes, Saturn was at a resonance with Neptune, and Neptune was the fourth thing that caused the instability in that moon's position. So the moon was not in a good circular orbit, a good stable orbit. It was being slightly going in close to Saturn or going out. And it could, if things lined up right, it could be flung away and we wouldn't see it. If it went in too close, then it went in inside the Roche limit. And both of those predictions are consistent with his model, but or each of those predictions.
I sent you a picture that I use at star parties of that first moon getting pulled apart. They're not pictures, they're artist representation.
Being pulled apart?
Yeah, the
Right,
Roche
right,
limit,
right.
Ron, means that
The Roche limit.
it got so close to Saturn that the gravitational tidal forces on one side and on the other side were so different that it overcame the bonding strength of the planet, depending on what it's made of course, easier with ice, and ripped it apart.
And so it might have, that planet, that moon might have been in closer to actually Io. We're talking about Saturn now, aren't we?
Yeah, yeah.
Okay, so
Well,
it
see,
was,
Io's rocky, so it can survive closer in than something icy could.
but Io's at Jupiter, so that's
Yeah.
okay. We're talking about the Io of Saturn that just couldn't take it.
Yeah, but an ice ball.
Oh, an ice ball, so ice and rock.
Yeah. And
Primarily ice.
the
apparently.
thing that the Roche fights being torn apart is the tensile strength of something. If it is a piece of steel, it's going to hold together and not break up much closer to the planet. But if it's just a ball of gravel or a chunk of ice, it's going to shatter and come apart farther out.
But then all large gas planets must go through something like this because they all have rings, at least in our sun.
Yes, with different size things, smaller things. Some of them capture. It's a multi-body process to capture.
I imagine the old web's going to show us maybe some rings in distant exoplanets, since that's
We've already found them.
Oh, you have?
Yeah.
Wow. And the Roche limit is not the same thing as a Lagrange point. It's not a similar.
No.
Well, it's
No,
similar in that it's a gravitational effect.
Yeah, but it's different for every body. So a strong body can get much closer. It has a Roche limit that's much closer to the large body. If it's a weaker structure, then its Roche limit is farther out. It's not a property of just the gravitational field like the Lagrange point is.
Yeah.
Would it be fair to say that all rings have to be exactly over the equator of that planet?
No.
Oh, they
No.
don't.
I would say they have to be.
Well, they have to be, they reflect the orbit of the original body.
Huh. So
Would you agree with that?
you couldn't have polar rings.
So if the body gets smacked by another big object, it's no longer in the plane. The rings don't move, it's the body does.
I think it's most probable that they are all lined up with the rotational axis.
Isn't Uranus on its side tilted?
Yeah,
Yep,
but
And
so
the
are
rings are
its-
tilted too. Its rings
Yeah.
are on its side.
Okay, so it would still have an equator. It's just up and down to us.
Yes.
And the rings are right above that for some reason. Huh. Wonder why that happens. Like connected to the axis of the planet for some reason.
Think about what it would look like if we had rings around the Earth, around the equator. You'd have this big, like, permanent rainbow over our equator in the sky. There would be pretty much only one object to look at in outreach.
Yeah.
Speaking of rainbows, Jerry, did you see this morning's double rainbow?
No, I didn't.
Yeah, it was probably around 6:30, 6:45. It was absolutely beautiful.
Yeah, that's late night for me. So did you get rain up there?
Just a little wisps. Yeah.
Yeah. We got our patio wet.
Right.
It
And
rained
that's
here
where
next to the ocean.
Yeah.
where the rainbow looked like it was emanating from, towards the university from our perspective.
Uh-huh.
Well,
Very pretty.
if we did have a ring around the Earth or some rings, it'd be hard to launch. About half our launches, especially the ones from ESA down in South America, would hit stuff.
That's true. That would interfere a lot.
Yeah. Be added to our.
Well, we may soon have one if if we get Elon and his buddies crashing a few of these satellites together.
Oh yeah.
Yeah, Chuck on Friday night pointed out at Westmont a string of those guys going up across the sky.
Yeah.
Wow.
They seem to be flaring. They would flare one after the other
that's
off
right.
into the kind of the northwest.
So you got a glimpse off of them?
Yeah.
Mm-hmm. Yeah, they would brighten and dim and brighten and dim. So they rotate, right, Chuck? They tumble. They tumble. Okay.
And they're not spherical.
Yeah.
I recall one Saturday night star party seeing a very bright, empty Chinese space station go over, and you'd think with that debris out there that we'd be seeing stuff all the time, wouldn't you?
We are, if you got a telescope.
Mm-hmm.
Well, very often you see things going through your field of your eyepiece.
But you can't track them with your telescope, so it must just go by like a meteor or something.
Yep.
Well, I mean, if you're at a couple hundred power and you've got, the 70, 80 degree field of view in your eyepiece, it takes a second or two for it to go across, maybe not even that.
Yeah.
You see them all the time.
And it's not just space stations.
No.
It's whatever.
No. It's
reflected.
estimated that when all these constellations of small sats go up, that they're talking 40,000 of these things, that the entire sky over the entire Earth will be brightened by about 3%.
Yeah.
Even if you can't see them individually.
And the other, another company is also going to launch a similar system. And I think China is going to launch a similar system.
Wow.
Collisions galore in our future.
Yeah.
Yeah.
Will they ever launch Artemis 1 or 2 or
Eventually.
3?
Eventually.
Eventually, you think so?
And one of the Starlink launches lost about half of the satellites that they launched, because they launched it and they used to go in a much lower parking orbit first, and they happened to coincide with a coronal ejection from the sun, with a solar flare basically, and that heats up our atmosphere and makes it expand, and so they lost something like 20 satellites right after launch because their orbits decayed.
Yeah. The air drag increased.
You suppose that happened to Sputnik, the first satellite, or is it still up there? Does anybody know?
I think it's still up there.
Yeah.
For crying out loud.
But that happened to Space Lab in '79.
Wow.
Yes.
Well, just like everything else, we pollute everything.
Yep.
So we're gonna have to change our.
Because Space Lab crashed in the far eastern part of Australia. I went home that evening from UCLA with $225 in quarters in my pants.
Ah, you had a pool too, huh?
Yeah.
We had one going at work for what longitude range it would end up in.
Okay. Now we just took a map of the Earth that had square grid on it, and you just put your name in a grid.
And 30% chance of land, 70% water, you won. I love it.
So Sputnik, it came down after 2 months.
Oh,
Oh, it did.
Oh, did it? Okay.
All
some
right.
of ours are still up there though, like one of the Vanguards,
Well,
one of the early ones.
We have second stages that periodically show up again after having orbited the sun for a long time.
yeah, but can you imagine the going after everything? You'd spend a fortune in fuel trying to catch up to things just to get rid of it.
Yeah.
How in the world are they going to do it? Gentlemen, we've run out of time.
Oh,
But
yeah.
This is one of the better ones, the 82nd, I do believe. 83 will be next week. And that's when Jupiter will be in some configuration, and take care of yourselves and your wives. Tom Totten, join us again, and thank you for being there for the planetarium, Mr. President. I hope you and I get reelected. If not, we'll just in December we'll just deny it happened. We'll say we won anyway. Okay.
You're in charge of elections. Can we trust you?
Oh, that's okay. I forgot
Are you
about
running? Are you running with opposition?
Yeah.
that. Well, unless you want to run, Bruce.
Only from the candidates.
No, I'm already president of the Theater Organ Society.
All right, everybody, tell your friends that we're here and we're going to meet again. And the rest of you, thank you. Give my love to your wives, and good seeing tonight with this overcast. Take care.